Now we're going to move on to the topic of significant figures first anyway, and then we'll move on to decimal places, something you've done before. But the first thing you need to know about significant figures to know when a figure in a number is significant. You can see some numbers here, and we're going to look at the rules that tell you when a digit of this number is actually significant. So significant figures could also be called significant digits. The first rule is that every non-zero digit in a number is significant. So that's easy to remember. Any number that is non-zero is significant. So in all these numbers here, 2, 3, 4, 8, 7, 2, 9, 2, 3, 3, 4, 6, 7, and so on are all significant numbers. This is an easy rule to remember. Second one says, every zero that lies between non-zero digits is significant. So something like 601. In the number 601, 6 and 1 are significant because they are non-zero. This 0 is significant because it's in between the 6 and the 1. That's the second rule. Or if you had something like 2, 3, 4, 0, 5, 2, 7. This 0 is in between non-zero digits, so it is significant. Next rule, every 0 that lies to the right of a decimal point and also to the right of a non-zero digit is significant. So what do I mean? Well, let's write a decimal number with a 0, 67.04. This 0 is to the right of the decimal point, like it's after the decimal point, right? A 0, but it's also to the right of a non-zero digit, 7. So this 0 is significant. And then the last rule is that leading zeros are not significant, and leading zeros are the following zeros. So if you have a number like 0.005, these zeros lead the number, they come before the first non-zero digits, so they are not significant. So you have a number where you just have zeros before you get to the first non-zero digit. All the zeros that precede the non-zero digit, the first non-zero digit, are known as leading zeros, and they are not significant. So here are some numbers here, and I'm going to let you know which numbers are significant and, well, which digits are significant and which digits aren't. So number 23, 2 and 3 are significant because they are non-zero digits. In 4872, 487 and 2 are significant digits because they are non-zero. In 902, 9 is significant because it's a non-zero digit. 2 is significant because it's a non-zero digit. 0 is significant because it lies between non-zero digits. 3, 3, and 4 are significant because they are non-zero. The 0 here is significant because it lies between non-zero digits. 6 and 7 here are significant, but 0 is not significant because it doesn't obey any of the rules here. I mean, it's not between two non-zero digits. It's not a leading zero is not significant. It doesn't lie to the right of a decimal point and also to the right of a non-zero digit. So here 0 lies to the right of non-zero digits, but it's not also to the right of a decimal point. So this 0 here is not significant. 2, 3, 2, 1, 2, 5, 1, 3, they're all significant. This 0 is significant because it lies to the right of a decimal point and to the right of a non-zero digit. 0 here is significant because it lies between two non-zero digits. This 0 and this 0 are significant because they lie to the right of a non-zero digit and to the right of a decimal point. In 0.003, 3 is significant, as I said earlier, but these zeros are not significant because they are leading zeros. These are the zeros that precede the first non-zero digit when you look at a number from left to right. So these are not significant. The 0 here is significant. So this 0 is significant because it lies to the right of a decimal point and also to the right of non-zero digits. So it's to the right of this decimal point and it's to the right of 5, which is a non-zero digit. So 0 here is significant. And this 0 here is significant, and it's not very obvious from the rules here, and it's significant because you can easily deduce that this 0 is significant because the zeros that follow it are all significant. So you could think of this 0 as being between significant numbers, and you can say significant, or you can think of it the following way. Imagine you measured something accurate to 2 decimal places and it was 10.00. You're saying that all of these measure, well, all the digits here are significant because you just carried as a measurement and it's accurate to at least 2 decimal places. So how would you now say that this 0 is not significant? You're going to find that you're going to have some problems where you have a number which has a certain number of significant figures, but you're then asked to approximate that number to a certain number of significant figures. So we're looking at how to approximate a number to n significant figures. The first thing you do is you count from left to right and you count n significant digits. So count n significant digits from left to right. And once you've counted n significant digits, the next digit to the right is the first non-significant digit. And you either round up or you round down the first non-significant digit. You round it up if it's 5, if it's greater than or equal to 5. And you round it down if it's a number that's less than 5. So let's move on to examples. We have the number 12,345. So 1, 2, 3, 4, 5. We need to round this, approximate this number to 3 significant figures. So SF here stands for significant figures. Well, let's count 3 significant figures. 1, 2, 3. So I write 1, 2, 3. And then the first non-significant digit is 4 here. And because it is less than 5, I'm going to round it down to 0. And then I'm just going to write 0 after that. So 5 also goes to 0. The second question, for example 2, we have this number here. We need to approximate it to 1 significant figure. So I count 1 significant figure, which is 1 here. The first non-significant digit is 3, which is less than 5. So I round it down to 0, and all the other digits that follow go to 0. So it's 1, 0, 0, 0, 0. So it's 10,000. This number here to 2 significant figures. So I count 1, 2. That's 3, 9. The first non-significant digit is 0. So I round it down to 0, and the digit that follows goes to 0. So it's 3900. This number to 3 significant figures. We have 1, 2, 3. The first non-significant digit is 8, which is greater than 5 actually. So you round it up. So 8 goes to 0, and then you round it up, so the 7 goes to 8. So you round up 8, so you add 1 to 7. So we have 5080. So this is a number to 3 significant figures. 5 significant, 8 significant. This 0 is significant because it is in between two. It's between non-zero digits. This 0 is not significant. 2.031 to 3 significant figures. Well, this is a significant figure. This 0 is significant. It is after a decimal point and to the right of a non-zero digit. This 3 is also significant. So the first non-significant figure is 1, which I'll round down because it's less than 5. So I have 2.030, which I don't have to write since it's a 0 after the decimal point. So 2.030. And then the last one, to 3 significant figures. We count 3 significant figures from left to right. So it's 4, 9, 9. And then the first non-significant figure is 9, which is greater than 5. So you're going to round up. So rounding up means 9 is going to go to 0. You add 1 to 9, which gives 10. So that's 0. And then 1 plus 9 again is 10. And 1 plus 4 is 5. So this is actually 50 points. 0 to 3 significant figures. So you drop this 0 here, and it's 1 to 3 significant figures. The 0 is significant because it follows a decimal point and it is to the right of a non-zero digit. And just so you know, in any number where you have decimals, any number with a decimal point, any 0 before the decimal point that follows a non-zero digit is significant. And now we're going to look at the procedure for approximating a number to a certain number of decimal places. So you can give in a number like 23.45, and you can be asked, well, first of all, notice that this is a number written to 2 decimal places. The 2 decimal places, 2 digits after the decimal point. And you could be asked to write it to a number in 1 decimal place. So what's the procedure? Well, for n decimal places, you have to identify the nth position by counting from left to right, so after the decimal point. So for 2 decimal, well, let's say this was this number. If you want to rewrite it to n decimal places, so 2, for instance, where n is 2, you count 1, 2 positions after the decimal point. And then if the digit in the n plus 1 position, so the position after n, so in this case, since n was 2, we're saying the digit in the 3rd position, n plus 1, 2 plus 1, which is 3. If the number is less than 5, round this digit down. And the next point just says, look, if that n plus 1 position, well, if the digits in the n plus 1 position, obviously to the right of the decimal point, is greater than or equal to 5, you round the digit up. And then finally, you just ignore every digit to the right of the nth position after you've carried out the preceding steps. And now, some examples. First one, in the first one we're given 34.48, and we need to rewrite it to a number to 1 decimal place. So you just count 1 digit after decimal point. Notice that the next digit is 8. It's greater than 5, so we round up. So we have 34.5, and then just ignore all the digits after the 1 decimal place. For this one, 32.54 goes to 32.5 because you count 1 digit after the decimal point. The digit after is 4, so you round that down to 0. So, done that. Next example, 11.468, 1, 2 decimal places. The digit in the 3rd position, so n plus 1, is 8. It's greater than 5, so you round it up. And by rounding it up, you know, you're going to have to add 1 to the digit that's to the left of the number of 8. So 6 becomes 7, 6 plus 1. So we have a number to 2 decimal places. Finally, 55.99. So this is 1 decimal place after, 1 point position after a decimal point. The digit after is 9. 9 is greater than 5, so round up. And that gives, well, so you round up 9, 0, and you add 1 here, so but 1 plus 9 is 10, so you have to write 0, and then carry 1 here to 5, which gives 6, and then we have 5, so it's 56.0, because you ignore every number after the nth decimal place. In this case, n is 1, so after the 1st decimal place, so 56.0 to 1 decimal point. 56.0 to 1 decimal place.